Alrighty, welcome back. This is Mr. Steele, and again we're working on standard quizzes from Term 3 at Franklin High School in Algebra 1. And this time I'm going to be covering standard quiz question number 5, which students must simplify an expression with a monomial to a power. So again, before I start and actually kind of explain some of the stuff, where I'm going to kind of start is give you an idea of what the problem looks like, and then probably over here I'll talk about a little bit of the strategies that I'm going to use and stuff I'm going to facts I'm going to use about exponents to make this work. So first let me just kind of write out an expression here. Okay, so this could be a problem that comes up on the standard quiz in standard quiz question number 3. And what we're going to be zeroing in on here is the fact that this part right here, this part is actually a monomial expression, so it's a series of factors multiplied together, taken to a power. And before we can actually simplify an entire expression like this, we have to be able to take care of the monomial taken to a power. So what I'm going to do is, the way I'm going to think about this is I'm going to think about what it means to have something to the third power. So you know I like stuff, so what does stuff to the third power mean? Well, if we think about it, exponents really just mean you're multiplying something over and over and over again. So stuff to the third power is going to be equal to stuff, hopefully I have enough room, times stuff, times stuff. Yes, I have enough room. So really, these two things mean exactly the same thing. One's just a really short way of writing it. Well, in order to simplify a monomial like this, I'm going to actually want to rewrite it this way so that I can actually multiply out each of the individual pieces together. So this is actually going to be my entire strategy, is using the definition of what it means to be an exponent. So if I go back over here, I'm going to work with monomial first. So that might be something to do, to note. Or since monomial is kind of technical, work with the stuff in parentheses first. So I want to deal with that part first before I get to the 3x squared. So in this case, I'm going to change my color here. I'm going to work in blue this time. So 2x squared y to the third, all cubed. That means 2x squared y to the third times 2x squared y to the third times 2x squared y to the third. Okay, no debating it. That's exactly what the exponent power 3 means. We're multiplying it by itself 3 times. Okay, so now, when I go to simplify this part, what I need to recognize is that I can kind of group the stuff together. So this is going to be the same thing as 2 times 2 times 2, x squared times x squared times x squared, and y cubed times y cubed times, well, y cubed. Okay, so looking at this, in order to simplify the monomial part, this thing, I just need to multiply all this stuff out. So 2 times 2 is 4, times 2 is 8. X squared times x squared times x squared, well that's 2, 4, 6 x's, so that's going to be x to the 6th power. Y to the third is 3, 6, 9. This will be y to the 9th power. So my monomial part up here, this guy, is now going to be written as 8x to the 6th times y to the 9th. So now in order to finish this guy off, let me go back to my black pen. We've now got 3x squared times my monomial, which is now 8x to the 6th, y to the 9th. So in order to simplify this off, again we just want to group the common factors together. So 3 times 8 is going to be 24. I'm going to do it a little faster this time because I trust you can get this. X squared and x to the 6th, that's going to be 2, 6 is 8, so x to the 8th. And then y to the 9th, well, y is the only guy there, so there we go. Our final answer, assuming I haven't made any mistake because it's kind of late, will be 24 x to the 8th, y to the 9th power. And there we go, we've simplified an expression with a monomial taken to a power. Okay, let's look at another example. Alrighty, so another example of dealing with a expression with a monomial taken to a power. So let's go with a slightly simpler one before going back to a little more involved one. Let's go with this. So notice in this case there's nothing out in front of the monomial. Like we just got basically the parentheses, the monomial expression taken to a power. So we're not going to worry about doing that last step. We're just going to have to simplify that guy. So to start that, again, just like the last time, where I'm going to begin is I'm going to think about what it means to take something squared. So when I've got stuff squared, that's going to be stuff times stuff. That's the definition of something squared, just like x squared equals x times x. Okay, so over here, I've got stuff squared. This is just my stuff. So I'm just going to rewrite it as negative 3 x to the 5th, y to the 7th, w times negative 3 x to the 5th, y to the 7th, w. Okay, so there we go. We've rewritten. Now there's no more exponents to deal with. Now I've just got to deal with this actual expression. And so again, the way I'm going to do that is I'm going to multiply the like factors together. So in this case, the parentheses can kind of dissolve. So I'm going to get negative 3 times negative 3, x to the 5th times x to the 5th, y to the 7th, y to the 7th, and w times w. Okay, so there we go. Everything's kind of matched with its partner. And so now we just got to actually multiply them. So negative 3 times negative 3 is going to be a positive 9. X to the 5th, x to the 5th, that's 5, 10. That'll be x to the 10th. Y to the 7th, y to the 7th is going to be y to the 14th. Then w times w is just like x times x is x squared. This will be w squared. And there's our final answer. 9x to the 10th, y to the 14th, w to the 2nd. Okay, so finally I want to do one more example, just to kind of hit it home, make sure you've gotten a couple here. So, only got one last sheet of paper. Let's come up with a couple numbers here. So this will be my third example. Let's go with sorry, I'm humming. Go this way. Okay, so here we go. We want to simplify the expression 5xy squared times the quantity negative 3x squared y cubed to the 2nd power. Okay, so what we're going to do, same as with the first example, we're going to start by simplifying the monomial. So I'm going to try to be consistent with my colors this time. So we want to simplify this guy first. Start with the parentheses. So something squared means the same thing twice. So the green is going to represent it by this. And again, some of these things you can probably start taking shortcuts and going a little faster. I'm just trying to make sure I explain it well each time. Okay, so now when I want to go through and simplify this, 3 times negative 3, x squared, y cubed. This is going to be 9 again, x to the 4th, and y to the 6th. And so there's our monomial part. This part's taken care of. Now what we need to do is we need to multiply that times this first guy, 5xy squared. So now we need to multiply that guy down. He's just kind of carried down. Okay, we'll do this looking at the common factors that are on both here that are both numbers. 5 times 9 is going to be 45. So I'm skipping a step here. X times x to the 4th is going to be x to the 5th. Y to the 2nd, y to the 6th will be y to the 8th power. So our final answer becomes 45 x to the 5th, y to the 8th power. And okay, I know that went briefly, but again, in standard 5, I think the best bet is to just think about what exponents really mean, and then kind of rewrite it out that way and simplify it in that way so that it becomes a simpler problem. And then from there, just making sure you multiply the same kind of factors together and simplify that way. So hopefully, again, this has been a useful video. You take something out of this, and standard 5 becomes one of your favorites. Although I realize you love them all, don't we? Don't we all just love all 10 standards? Okay, have a good night.